3. What is density? So, the way I like to see density, personally for me, is kind of like the amount of mass in a given area, if that makes sense. So, density, okay, what is that? I see it as like the distribution of mass over a certain area. And yes, they do have a formula there, you know, the density sign. It looks like a P, kind of like that, is equal to mass over volume, okay? This is volume, this is mass. This is the formula right here for density. But that doesn't really conceptualize it, does it? You just give a formula and you kind of have to visualize it. So, if we're going to make some examples here, think of, I guess, suitcases, right? You know, like when you fill it up, usually like, and you lift it up there, so you have a whole suitcase bag, and then there's stuff in it. All right, you can say the whole thing is like 50 kilograms. That's the mass. But you could also say that this area here has a greater density than this area here. This density here would be less. Why? Because the stuff's near the bottom. Exactly. So if I kind of like took the volume of this area here and divided the mass by that volume, I'd get a higher number than if I just divide it by the whole volume, because you kind of have to, it's kind of how the mass distributes itself. A better example of density would be, for example, if you had two things that weighed the same. Let's say this was like 50 kilograms, but this thing also weighed 50 kilograms. Imagine if, like, exactly like you are, aluminum foil actually is a perfect example, actually, because remember how if you, so let's say you had a whole giant sheet of aluminum, really heavy sheet, I guess, because it weighs 50 kilograms, but then you were able to compress it all the way down to this rock solid aluminum ball. Same mass, but this is way denser, and you'll feel it too. As in this, you know, those 50 kilograms, you could probably like punch through it if you tried hard enough. You could pop a hole in this thing, bam. But this, there's no way you're gonna get through that aluminum because it's so tightly packed with each other. So that's how I visualize density there. If they ever ask you to explain it, just remember that the volume plays a key role. So two things can definitely weigh the same thing, but one can be denser than the other based on like how much volume there is. Another example is like people in general, actually. You've seen like tall people, and they would weigh the same as like a shorter, stockier person, for example, but they would have the same weight. Let's say like this is like 70 kg, both of them. This person is more dense. You'd probably assume that if these two weigh the same, the shorter one would probably maybe have more muscle mass or fat or something, just because there's like more, it's kind of like he's more knit up in a certain area. Just be careful though, because you have to make sure that you are calculating the volume right, because for example, if it was like a tall skinny person and like a short much stockier person, they could actually end up having the same volume, so they'll be around the same density. So if you ever want to think about density, I would always kind of just refer to the aluminum example, because that one you can really conceptualize, and you can grab any paper, crunch it up, and you'll see that it's more dense, and you'll feel it based on the paper that's completely laid out flat. Okay, so this is correct because they have the right formula, mass over volume. And now let's move on to question 4.